We're going to look at part one of graphing polynomial functions. So we're just going to be introducing polynomial functions today. First thing we need to do is cover some vocabulary words. We're going to look at degree. And when you hear the word degree, what that is meaning is that we're looking at the highest exponent. So if my highest exponent is 5, then my degree would be 5. The leading coefficient, that is the coefficient of the term with the highest degree. Remember, a coefficient is just the number part. The constant term is the number that does not have a variable. And standard form is when our function is written in descending order of exponents. So if I had 7x to the fourth plus 3x squared minus 8x plus 2, these are in descending order, 4, 2, and a 1. Okay, we're going to be looking at different kinds of polynomial functions, so we're going to go over the parent functions first. And if we have a degree of 0, we call that a constant polynomial function. And it's going to look like f of x equals a sub 0, or an example would be f of x is equal to 8. Now, when you have a function like that, your graph is going to be a straight horizontal line. This is like saying y equals 8. Okay, now if our degree is 1, that's going to be your standard linear equation, where you have y equals mx plus b. Well, when we write it as polynomials, we would put a sub 1x plus a sub 0x, or a sub 0. An example would be 3x plus 2. So when we have a linear graph, it's just going to be your standard line. Now the 2, if our degree is 2, that's our quadratic. So we would have something with an x squared in it. I've got 4x squared plus 3x plus 2 here. Anytime we have a quadratic or a degree of 2, we get the parabolas. Okay, the third one is cubic. When we have something that is cubic, that means our highest exponent is a 3. So our degree would be 3. And what these look like is they will have form like a little squiggle in them. And then 4 is quartic. That means our highest exponent is a 4. So I've put this example here in standard form. And when you have quartic, it can look like two different types of graphs. The first one is it can actually look just like a parabola. And the second one is it'll have a little bit of a bump in the middle of it. So it won't just be a smooth parabola, there would be a bump. So those are what our parent functions are going to look like. You'll want to refer back to these when we get to the point that we're actually graphing, so you know what the shape should look like. Okay, so here's going to be our first example. I want to state the degree, the leading coefficient, the constant, the type, and sketch the general shape, then write it in standard form. So as I look at my function I have here, f of x equals 2x squared plus 4 minus 3x plus 6x to the fourth. I'm actually going to write it in standard form first. That way I can get it better organized. So as I look through here, the plus 6x to the fourth is the biggest. Then my next exponent is x squared. So I'm going to have plus 2x squared. My next exponent would be this minus 3x. And that leaves my constant term of plus 4. So here we've got it in standard form. Now it's a lot easier to find what my degree is because it'll be on the first term. So state the degree. Well, the degree would be 4 because my biggest exponent is a 4. The leading coefficient, that's the number with the term that decides the degree. So in this case it would be 6. And our constant is that 4 on the end. The type of graph. Now when it asks you for the type of graph, it's wanting the name. Is this a constant, linear, quadratic, cubic, or quartic? Since we have a degree of 4, it would be quartic. And then we need to sketch its general shape. Well, it's either going to be like a parabola or kind of like a W. Now we're going to look at evaluating polynomials. The first one is direct substitution, and that's what we have generally done in the past. When we see f of 3, that's telling us that x is equal to 3. So we come over to our equation and we plug in 3 wherever we have an x. Once we get that plugged in, we can go ahead and evaluate it. So we would have 2 times 9 plus 4 minus 9 plus 6 times 3 raised to the 4th is 81. So 6 times 81. And then we can go ahead and do the multiplication. So 2 times 9 is 18 plus 4 minus the 9. Take that 81 times the 6. And we get 486. Now I can go ahead and add and subtract from left to right. Make sure you go from left to right. So the 18 plus 4 gives me 22. Minus the 9 gives me a 13. And plus the 486 gives us 499. So our final answer for this one would have been 499. Now we have a second method for evaluating these, and it's called synthetic substitution. What we'll need to do is first write our function in standard form. So I'm going to rearrange this one so it's f of x equals the 6x to the 4th plus 2x squared minus 3x plus 4. Make sure I got them all. So I've got it written in standard form first. Now for synthetic substitution, we set up kind of a bracket here, and across the top we put our coefficients. Now one thing you have to be aware of is for missing terms. So as I look back at my function, I have 6x to the 4th. I don't have any x cubes, so I would have 0 of those. And then everything else is present. So I would just need to be aware that there's 0 x cubes, because when I do synthetic substitution, I have to include every single position. So since I start with the 4th power, my next number has to be the 3rd power's coefficient, then the 2nd power's coefficient, then the 1st power's coefficient, and my constant. So I would have 602, negative 3, 4 going across the top. Then I take this value, the fact that x is equal to 3, and that gets put on the outside of my bracket. First thing I do is bring down that leading coefficient of 6. Then I'm going to multiply. The 3 times the 6 is an 18. From here, I add 0 and 18, and I get 18 again. Then I repeat that process. So I would take 3 times 18, which gives me a 54, and 2 plus 54 is 56. Then I repeat it again. So 3 times that 56 is 168. Add that to a negative 3, and I get 165. And then I go back and repeat again. So 3 times 165 is 495. And then 495 plus 4 gives me 499, which is the exact same answer that we got when we did direct substitution. Now, it's really important to learn the synthetic substitution because it's a process we will be using in a later section. So right now we just need to practice the process of synthetic substitution. Okay, here's what I want you to do. I want you to bring these two problems to class. Notice the bottom one says to use direct substitution and synthetic substitution. So make sure you do both processes for this last one.